The concept of stoichiometry is the mixture of dimensional analysis and balanced chemical equations. I'm going to give you a couple of examples showing you how to use a balanced chemical equation to determine the quantity of reactants or products within that equation. My first example is solid aluminum added to gaseous oxygen to produce solid aluminum oxide. The first thing I need to do is balance this equation. So I notice that my oxygens are a 2 to 3 ratio, which means the least common multiple between them is going to be 6. So I'm going to put a 2 and a 3, so I have 6 oxygens. And that makes 4 aluminums, so I'm going to put a 4 in front of my aluminum. Now that I have this balanced chemical equation, there's something called the mole ratio. This is showing that I have 4 moles of aluminum, 3 moles of gaseous oxygen, and 2 moles of aluminum oxide. This is called the mole ratio, and it's going to be very important when you're dealing in stoichiometry. So let's get to the question. If 5 grams of aluminum is used, how much aluminum oxide can be produced? So I'm putting in 5 grams of aluminum and I want to know how much of the product I can get out of that. Okay. So the first thing I'm going to do is figure out what I have and what I am looking for. So I know that I have 5 grams of aluminum and I'm asking how much aluminum oxide can be produced. If I'm asking how much, I'm really looking for grams of aluminum oxide, and it's a solid, so I'm going to go to grams on that one. Alright, so my known is that I have 5 grams of aluminum, and my unknown is the mass, or how much of aluminum oxide I'm looking for. So you start with what you know, set it up into a T-chart. I know I have 5 grams of aluminum. The only place I can go out of grams is into the mole, so I'm going to put grams of aluminum down here for every 1 mole of aluminum. The molar mass of aluminum is 26.98 off the periodic table. Right here, 26.98. So I'm out of grams of aluminum into the mole of aluminum. It's really important that when you're doing stoichiometry that you put the compound or element by each step to be methodical about it. Okay, so now that I'm in the moles of aluminum, I don't care about aluminum. I care about aluminum oxide. And so what stoichiometry does is it gets you out of one element or one compound into another. The only way to do that is using the mole ratio. So up here I know that I put in 4 moles of aluminum and I got out 2 moles of aluminum oxide. So I'm going to use on this next step the mole ratio, so that I can get out of one thing into another. I know that moles of aluminum has to go in the denominator because moles of aluminum is in the numerator up here, and I know that there are 4 of them. Well, I want to go into aluminum oxide, and the mole ratio allows me to do that. So for every 4 moles of aluminum, I produced 2 moles of aluminum oxide based on my mole ratio. So now I'm in moles of aluminum oxide. Using the mole ratio, I can now say that for every 1 mole of aluminum oxide, I have the molar mass in grams of aluminum oxide. So I need to find the molar mass, which would be 16 times 3 for my oxygens, plus 26.98 times 2 for my aluminums. 101.96 is the molar mass. So 101.96 in grams. So I started off with grams, went to moles, went to the mole ratio to get out of one compound into another, and then back into grams of my second compound. All right, so now that I've reached the units of my unknown, I stop. That's what I'm looking for. Multiply numerators, divide by denominators. So I'm going to take this number that's already in my calculator, multiply by 2, and multiply that by 5. So those are all my numerators. And then divide by everything on the bottom, so 26.98, and then divide by 4. So 9.45. 9.45 grams of aluminum oxide can be produced. My next problem, the first thing I need to do is balance this equation. And so let's start. So I have 3 sulfates here, so I'm going to put a 3 there. I now have 3 calciums, and I now have 6. 2 times 3 is 6 hydroxides, so I need to put a 2 over here in front of the hydroxides. 2 aluminums, 2 aluminums. Okay, so this is a double replacement reaction. I take 2 aqueous solutions and I produce an aqueous solution and a precipitate. So the question says 3 milliliters of calcium hydroxide is added to aluminum sulfate. How much of the precipitate is created from this reaction? So let's figure out what the mole ratio is first. So I have 3 moles of this, 1 of this one, 3 moles, and then 2 moles. So based on the balance. So the reason why this is in milliliters is because I added 2 aqueous solutions together, and that means that I'm going to have to use 1 mole equals 22.4 liters as a relationship. And the thing is it says how much of the precipitate. A precipitate is a solid, therefore I'm going to be looking for that in grams. So what do I know? I know that I have 3 milliliters of calcium hydroxide. What don't I know? The mass of the precipitate, which is aluminum hydroxide. So I have my starting place and my finishing. So you start with what you know, set it up into a T-chart, and I know that 1 mole equals 22.4 liters, but this is in milliliters, and so I'm going to say that for every 1,000 milliliters I have 1 liter just to get out of milliliters. And then I know that 22.4 liters, which has to go in the denominator, equals 1 mole. Okay. And I'm in calcium hydroxide still. So now that I'm in moles of calcium hydroxide, I can use my mole ratio. So I know that I need moles of calcium hydroxide in the denominator to cancel out with this up here, and I know that I have 3 moles of it. So I'm going to put that there. Well, I want to get out of calcium hydroxide into aluminum hydroxide, and 2 moles of aluminum hydroxide were produced. So now I'm completely out of calcium hydroxide and into aluminum hydroxide. And now that I'm in moles of aluminum hydroxide, I need to go to grams, and so I can just say that for every 1 mole of aluminum hydroxide, I have the mass of aluminum hydroxide. And so I have 3 hydroxides, so a hydroxide is 16 plus 1.01, multiply that by 3, and then add aluminum, which is 26.98. So my mass is 78.01, like that. All right, so now that I'm in the units of my unknown, I stop. All my other units canceled out. So I have nothing left but the units of my unknown. Multiply your numerators, divide by your denominator. So I'm going to take 78.01 times 2 times 3, and then divide by 1,000. And then divide by 22.4, and then divide by 3. I should get a really small number because I'm starting out with 3 milliliters of an aqueous solution, which is a very tiny amount, and so this small answer makes sense. So I'm going to turn that into scientific notation that I produced, let's say 6.97 e to the negative 3 grams of aluminum hydroxide. And there you go. And that's stoichiometry.